these composition of functions, and today we're gonna go a little bit deeper into them. And yeah, a little bit deeper, not too much though. I just want to review really quick. Do you remember what the difference is between this problem and if you saw something like this? What's the difference between 63 and this one right here?
Nothing.
Nothing. Good answer. Good answer. So the only thing different is the way it's written, but it's really, they're the same problem. What does this mean then? What does f of g of 1 mean? Can you tell me? What do we do with f of g of 1? F of g of 1. Now, just to remind you,
It's just f times g, right?
no, there's no timesing. This does not mean times. What does f of g of 1 mean?
You
Go
plug,
ahead.
you plug something in for something.
1 in for the f.
1 in for where?
G.
Good. 1 goes into the g function.
And the outcome goes
So
back.
when you put a 1 in to this g function, what do you get?
3 times 1, which is 3.
Okay,
Plus 2
3
is
times
5.
1. So what is 3 times 1?
It's 3 plus 2 is
And
5.
3 plus 2 is 5, so you get 5. Now what do you do with 5?
Put it into the
Good, you put 5 into the f function. And you get, what is 5 minus 2?
3,
And what's 3 over 3?
1.
Okay? Now, what about this, go to 67. What's this g of 0?
What's the final answer of that? 5 and 1?
1,
Oh,
just
just
1.
one. Okay.
This is the final answer, 1. So what does this g of 0 mean? What is it telling you to do?
Plug 0 in for g.
Plug 0 in for g. So if you put a 0 in here, what do you get?
2 times 0 is 0, plus 2 is 2. And plug 2 in for 2 minus 2 is 0.
Very good. So g of 0 comes out to be a 2, and now you're going to plug 2 into the g function, and what do you get?
6 plus 2 is 8.
Good. So your final answer is 8. You guys got that?
Yep.
Okay, now, I want you to flip to the next page. Example 5. Here's 2 different problems. You're going to find f of g of x, and you're going to find g of f of x. What's the difference? Can you tell me the difference between these? These are the same. We already stated that. These are asking the same questions, but why are these different? What does one mean versus the other? Anyone?
You're looking at different answers.
You may get a different answer, yep. But what's this one telling you to do versus this one?
You just flipped them. You just multiplied them.
Here you go.
Wouldn't it be the same?
This, nope, you're not multiplying.
Oh, okay.
This composition means you're plugging x first into the g function and the result goes into the f function. Versus this one, you're plugging f into the f function and then the result goes into the g function. Now, what's the definition of the f and the g function? Well, for this particular problem, the f function is 2x squared minus 1, and the g function is 3 times x. So let's see what we get. These are 2 totally different problems, and you really have to pay attention to the order of this, how it's written. These are 2 different answers. This one is saying, this is directing you to take x and first stick it into the g function. Well, if you put x into this g function, you're gonna get, what? You plug x into the g function, what do you get?
3x.
You get 3x. So you get 3x. So now you're gonna do f of 3x. That result goes into the f function. So where is f of x? It's right here. So where you see x in this problem, you're gonna substitute it for 3x. So we're gonna take this now. You're gonna do 2 times 3x squared, and then minus 1.
I am a little confused.
2 times 3x squared minus 1. I'll rewrite it.
So you plugged x in for g, so that's where you got 3x, right?
And then the outcome of that.
So you plug 3x into the f function. So the f function is 2x
Mhm.
squared, so
So instead of using a number, we have a letter. So if I ask you to do f of g of x, it's easier if I show it this way.
letters.
Okay, I know. You're gonna plug, see this goes first. You're gonna plug this, I like to draw arrows. X goes in here.
Yeah.
So what comes out? What's this part right here? What's g of x? If you put an x in here, what do you get? What comes out?
Squared?
No,
I
if
don't
you
get
plug
it.
x, if you put x in here, what do you get? If you just plug an x right in here. So in other words, where you see x, you're gonna replace it for x. So here's an x.
Just 3x, right?
You get 3x, yeah. You get 3x. So this thing is really what is your definition of g of x.
Okay.
So 3x, you get 3x. So now, so this piece is equal to 3x. Now you're gonna put this into the f function. So this whole thing, where you see x, you're gonna put a 3x. So you've got 2 and then 3x, but it's squared, and then minus 1. Does that make sense? A little bit, kinda? So can you do this problem?
No.
Why not? Anything, can you simplify? Can you square that quantity?
No.
Yeah, you can.
Yes, yeah, sure.
3x quantity
You get-
squared is
you get-
really what?
9x squared.
Good. This is 9x squared, and then times that by 2. What do you get? What's 2 times 9x squared?
18x squared.
Uh-huh. So this is what 18x squared minus 1 is really what f of g of x is.
So that's the final answer.
Yes, this is the final answer. That's the final answer. That's f of g of x. What you did was you put x in for g, and what came out, the outcome, goes into the f function. I know. So then, what do you think? So that's f of g of x. What's g of f of x?
Just the opposite.
What's g of f of x? When you say
You
opposite,
just plug the x in for the f now.
yes, now you're gonna do the reverse. You're gonna plug this in here. If you plug x in here, what do you get?
The same thing.
You get the same thing, thank you. You get that. Now we're gonna take this
And plug it in for
and
g.
plug it in the g function, so where you see x, you're gonna substitute this in for x. So what do you get? 3,
3 times 2x squared minus
and what is 3 times 2x squared?
6x
6x squared,
minus 3.
that's your final answer. Now you guys said it's the same thing. Did they come out to be the same answer? No. They did not. So can you do it in any order you want? No. You have to follow the instructions. If you were baking something and it said, first mix the water with the flour, follow the instructions, right?
Yeah.
So that's exactly what you're doing. You're following what they tell you to do. You don't jump in whatever order you want it. So this one is telling you to plug first X in for G, and then that answer goes into the F function. So what I want you to do, you're gonna skip 76 and 77. There's 4 problems here that ask you to practice this, what we just did. What you have to do, and I'm sorry, there's not a lot of room. Let's do 72 together, and then you're gonna practice 3 more on your own. It says f of x is defined as 3x. So f of x is 3x, and g of x is x squared.
Okay.
You're gonna do 2 problems here. I need f of g of x,
Wait, where does it say, are you
right here,
oh.
in the directions. For each pair of functions, find f of g of x. This is your pair of functions. And you're gonna find the reverse, the g of f of x. Let's do this one first. So if you have to, you guys rewrite it and draw arrows. So the f of the first one, this is the A, and we'll call that B. So A, you're gonna plug x into the g function. So x goes in here. What do you end up getting?
X squared.
X squared.
And then you plug X squared.
And then you're gonna plug this into the f function.
So it would be X squared, or 3 times X squared.
Yes. So then 3 times x squared. That's your answer for that. For f of g of x, it's 3x squared. Then how do you do B?
Plug X in for F.
Good. So you've got g of f of x. You're gonna plug f into the, x into the f function, so you get what? If you plug x in here, what do you get? 3x. Now you're gonna plug this in here.
Be 3X squared.
So 3x quantity squared. What's 3x quantity squared?
9X
9x
squared.
squared. That's your final answer. So f of g of x is 3x squared. G of f of x is 9x squared. They're 2 different answers. Mr. Duke, do you have anything to add? This is the hardest section. This is the hardest. This is the most confusing.
I think I get it.
You think you get it? Okay, now, flip this over. These are 2 excellent, you guys always ask, when do we need to know this? Okay, here's, what do you do first? These are 2 good examples. We're gonna do these together.
It's a short
You've
one.
got a coupon. I'm giving you all a coupon for $5 off a pizza, any large pizza. And the pizza, Jets is my favorite. Okay, so I'm gonna give you a $5 for being a good student, showing up today. I'm gonna give you a $5 off coupon, a large pizza. And Jets offers, if you show them your ID, you get 10% off a large pizza. What do you do first? Do you hand them the coupon and then get the 10% off?
No, you get the 10% off first and then.
That's what you'd rather do?
Yeah.
Why? What's your reasoning? Are you saving money?
Wait, it might be the opposite way.
Oh, well, let's investigate.
Oh,
Let's figure it out.
yeah, okay.
See, you don't know. What if they ask you? What do you wanna do? What are you gonna do?
Well, I will
10%
pull out my
off a larger number
calculator.
is more, isn't it?
Okay, let's see.
So taking $5 would be.
Let's pretend like the pizza cost $10. Let's use $10 for the cost of the pizza. Okay, so if you give them the $5 off coupon first, so the pizza's $10, if you take $5 off that, the pizza's $5. Let's say you forgot your ID. Okay, let's say you have your ID on you. How much are you gonna pay? If you're saving 10%, how much are you paying? Everything comes out of 100%. So if I'm gonna save you 10%, what portion is left? 90%. You're gonna pay 90% of $5. How much is that? That's $4.50. So if you give them the coupon first, and then you get your 10% off what's left, you're gonna pay $4.50. Let's look at the other way.
If you're gonna save more money this way.
You think that's the better?
The up this way, the
Yeah,
10%.
okay. Now, if you gave them your ID first, what is 90%? Because you're saving 10%, that's $9. Now we're gonna apply our coupon.
We're only paying 4.
You're only paying $4. So, how much of a difference is it?
50 cents.
It's 50 cents. Now, what I did is I did it with a bunch of different examples. Yeah, let's see if I can find it. Yeah, I can't find it. I tried doing it with,
Oh, it's supposed to work.
different dollar amounts here. I have it right here. To show you. What if the pizza was $15? And you took the coupon off first and then the 10%, you pay $9. If you did the 10% off first and then the coupon, it's $8.50. So what's the difference? And then I did a $20 pizza. It's the same. How much are you saving by doing the percentage first? It's 50 cents. In every case, it's 50 cents. So by applying the discount first and then taking the coupon off, you're gonna save yourself 50 cents more, 50 cents. Now look at this question. This is where it's gonna fool you. Read the next one. Okay, your teacher is offering you, if the whole class does well on this test, she's gonna give everyone a 10-point bonus and increase your score 9%.
90.
90%, that'd be nice. 9%. What would you rather have? Would you rather get the 10 points first and then increase your grade 9%?
No.
Or would you rather increase your do your 9% and then get 10 points?
Yeah, the 9% and 10 points.
No,
No?
other way,
Why?
because
If you
then,
have more points than that.
Oh,
Yeah,
yes,
but
the
it'll
other way,
increase.
yes.
Okay,
I get it.
let's do it then.
Yeah, you
So-
got it right.
What's your score? 75. So if you add 10 points to that,
This is a trick question.
that's an 85, right?
Yeah.
Now we're gonna increase your grade 9%. Now, do you know how to do that in one shot? What do you multiply 85 by? 1.09. Because that's going to add the 85 and it's gonna add 9% of that score. So if you multiply 85 times 1.09, you get 92.65. That would be your grade. Versus, who said they wanted to do the percent first? Everyone did?
He did.
He did? What did you say?
I said
The points first.
I changed
So-
my mind.
He changed his mind. So 75 times 1.09 is 81.75. And then if you add 10 points onto that, 81.75 plus your 10 points is 91.75. What grade would you rather have?
82.65.
This is an A minus in my book. This rounds to an A. So in this case, you want the higher score, but the pizza, the higher score was not what you wanted. You don't want to pay more for a pizza. So it depends on the situation. If you're talking about money and what you're paying for, you obviously wanted it to be less. But when you're talking about your grade, you want a higher grade. So in this case, doing the percent first was the better choice. Does Does that make sense?
Yeah.
So how did I know? I did a sample, and I looked at my numbers, and you have to actually compare the two numbers based on what you want. Do you want a higher number or a lower number? In the pizza case, you wanted a lower number, because that's what you're paying. In the grade, you wanted a higher grade. So to answer this question, would you rather have the 10-point bonus first and then the 9% increase, or would you rather have the 9% increase and then the 10%, or 10
first.
point? You'd rather have this one. You'd rather get the 10, this is what you'd rather have in this case. Okay? So if someone asks you that question, you'd be able to figure it out, right? All right, for the rest of the time, I'm gonna have you guys work on this packet. Now, when you're done with it, the whole packet should be done. Please turn it in. If you need the weekend to finish it and turn it in on Monday. It's worth 3 homework assignments, okay?
9 points.
9 points.